Hello, today I will show you and tell you how to make a CNC plotter with your own hands. To do this, we need a chipboard sheet, in order to secure all the necessary things on it. Also, we need plastic parts printed on a 3D printer. I modeled most of these details myself, leaving a link to download them in the description. Pulley I printed nozzle 0.2mm. Still need some screws, bolts and nuts. Also need shafts, only 6 pieces, 2 shafts with a diameter of 8mm, 45 cm long. 2 shafts with a diameter of 6mm, about 36 cm long. I took these shafts with unnecessary paper printers. So, it was decided to use Arduino Uno as control. 2 drivers of stepping motors ULN2003 and the stepping motors themselves. The servo, which will raise and release the writing element, will all be mounted on the breadboard. All these components that you see now were bought by me in the 3v3 store. I will leave all the necessary links in the description. We collect the scheme. I will also leave a link to the scheme in the description. As you can see, for convenience, I soldered the plug on the back side of the Mayplate board and set a smoothing capacitor for 1000 microfarads at the input. I still need a power supply unit for 5 volts. I advise you to take 2 amperes with a current. By the way, 6mm shafts with belts sold to my friend for cheap. As I said earlier, 6mm shafts with belts were taken from the printers. I also decided to buy a waterproof marker that will draw over the foil Textolite. Thus, I plan to make with the help of this CNC machine printed circuit boards. Mainly PCBs will be manufactured for smart lamps, which are developed by our Einvention team. Lamps will go on sale this July, so sign up to not miss such an important news. Now you can before you all what is needed to assemble a CNC plotter. Guys, if you use a regular Arduino cable, then you will not be comfortable, because the wire itself is very short. I found the same 2-meter cable here. It also seems to be taken from an old paper printer. So, we put on the sheet the first part that will mount the shafts. For fixing the necessary parts, I took these screws. It is necessary to fasten parts as precisely as possible. I drilled all the necessary holes in advance, before how I started shooting this video. So, we twist the first screw, we expose the detail exactly, and then we twist the second screw. So, we twist the first screw, we expose the detail exactly, and then we twist the second screw. So, then we take 6mm shafts and insert them into the corresponding holes. You can put here 8mm shafts, then the total construction will be more reliable. As you can see, we have a roughness, but that's okay. The main thing is to drill holes so that our parts are opposite each other. Twist the screws again, and unscrew them, because we need to put the shafts in their place. We put ourselves shafts. Guys, now we take the table itself, and as we see, such linear guides go to it. They consist of 2 parts, the sleeve itself and the linear guide. So, we take the insert sleeve and carefully hammer it into place with a hammer. Due to the fact that the sleeve is slightly formed, it needs to be further drilled. Also, you need to lubricate the shaft itself. This is necessary, because without this, the friction of the sleeve on the shaft will be much more and the sleeve itself will be erased faster. We take our table and fasten linear guides to it. As you can see, I screwed only 2 bolts on each linear guide, instead of 4, because I lack them. The table itself consists of 2 parts, which are fastened together with the help of such studs. The studs can be replaced with bolts. When assembling the table required, this melting should be equal to this. The more precisely this indicator, the better. Now, we collect everything as shown in the video. And we got an almost finished Y-axis. The table should move freely, without much effort. Now, we mount the stepping motor itself to the specially designed part for it. The pulley turned out to be quite good. Its main thing is to print a nozzle of 0.2 mm. We make the fastening of the belt, which will be located opposite the engine itself, and fasten it. Originally put so, we fasten the mount with the engine to the table. And now we stretch our belt, which is also taken from the old printer. From what exactly this belt was removed, I cannot say, since the belt itself with the shafts bought from a familiar person. On the one hand, I decided to tighten the belt on a regular knot. From the second side, I secured it with Scotch tape. Now as the pulley rotates, the entire table should move. So, now I need to put the roller exactly. For this I took the washers on one side and spun 2 nuts on the other side. We put the mount, which will fix the X-axis at the distance between them as the length of the shafts themselves. In my case, the shafts are 45 centimeters long. Hence, and the distance between the mounts is more than 45 centimeters. Fastening to a sheet of chipboard. I got crooked for some reason, but that's okay. This will not affect the performance of this machine. Again, insert the shafts in their intended hole. And now we need to assemble a carriage that will travel along the X-axis. As we can see, here I have already printed others linear guides. They use less plastic, but they are worse, because the walls are thin, and when subjected to force on them, they sort of shrink and the friction of the linear bearing on the shaft increases significantly, respectively, and the load on the engine also increases. Models that are designed for assembling the carriage itself, all holes are intended for bolts with a diameter of 3 mm. Unfortunately, the required number of bolts I did not find such a diameter, so I drilled all the necessary holes with a 4 mm drill. So, we collect everything as shown in the video. So here we also insert the bolts that will fasten the belt on themselves and twist them. We put under one washer for reliability. On this side, we pass through one bolt and fasten a part that is intended for fastening the writing element. fasten the belt to the bolts. This is how it looks. From the second side we also fasten it. We shove our carriage on the shafts, as shown in the video. The carriage must also move without much effort. And here we look at our CNC. So, now we will assemble the mechanism with a skating rink and fasten it into place. As you can see, the belts should not be too tight and not very loose. The wires from the servo are additionally lengthened. Fasten gear to it, and the servo itself is fixed in its designated place. Now there is a small problem. Since linear bearings are very thin and are afraid of impacts on them, if we take and tighten this nut, then the bearing will shrink and significantly increase friction on the shaft. In order to avoid this, I decided not to twist it strongly and pour hot water in the right places. Glue. We put on a rubber band on the writing element itself. We pass it here and clings to the rail. Now, when raising or lowering the slats, respectively, the markers should be released or raised. To avoid any play, the bolt can be screwed in here. Let's calculate the total costs. The mass of plastic spent on printing all the parts is about 350 grams. You can see a small expense report now. Guys, I can see 3D printing on order and I can print all the necessary details for you. How to contact me, you can find in the description. This was the first part of the video on how to make your CNC machine. In the second part 1 we'll talk about what programs to use, what firmware and how create your decode. Please subscribe to the channel to not miss anything. I left the link to the store where I bought the electronics in the description, also leaving the link where I bought 8mm shafts. Also, in the description you can download the scheme and models in order to print them. The second part will be released soon. Thank you all for watching. Bye everyone.